Approximately 14 billion years ago, the cosmos was shrouded in an encompassing veil of darkness. But how did the entirety of existence emerge from a state of absolute nothingness? It's the kind of question that invites us to look beyond our everyday lives, to gaze into the vast expanse of the cosmos and ponder our place within it. It's a question that takes us on a journey back in time to the very origins of the universe itself. The answer to this question is what we'll explore today as we delve into the Big Bang Theory. Imagine everything in the universe compressed into an infinitesimally small, infinitely hot, infinitely dense point. This is the Big Bang Theory, a concept that has captivated the minds of scientists and laymen alike. Approximately 13,800 million years ago, our universe was in an extremely hot and dense state. Then, in an event that can only be described as the ultimate explosion, the Big Bang occurred. The energy released was so immense that it gave birth to all the matter and energy that make up our cosmos today. In the earliest moments after the Big Bang, matter and antimatter were in abundance. These two opposing forces collided violently, yet in a mysterious twist of cosmic fate. Slightly more matter than antimatter survived this cataclysmic clash. This imbalance laid the foundation for the formation of everything we know. But the universe as we understand it today didn't form immediately. Instead, it was filled with a dense soup of fundamental particles called quarks and gluons. As the universe expanded and cooled, these quarks began to combine to form protons and neutrons, which eventually came together to form the nuclei of the first atoms. The universe continued to expand and evolve over billions of years, with galaxies, stars and planets beginning to take shape from these primordial elements. The story, however, doesn't end there. According to current cosmological models, the expansion of the universe may eventually slow down and reverse, leading to a big crunch scenario where everything collapses back into a singular point. This cyclic view of the universe suggests that our cosmos may be just one iteration in a never-ending cycle of creation and destruction, with countless Big Bangs occurring throughout eternity. Just as we observe cycles in nature, such as the changing of seasons or the water cycle, the universe itself may be part of a grand cosmic cycle, constantly renewing and evolving in an endless dance of creation and destruction. Under this framework, the universe resembles a pulsating heart, with each expansion, Big Bang, followed by a contraction, Big Crunch. We, as inhabitants of the cosmos, find ourselves merely within a single beat of this cosmic rhythm. In the immediate aftermath of the Big Bang, the universe was a hot, dense soup of particles. It was an inferno of energy, a seething cauldron of chaos wherein the fundamental building blocks of the universe were born. In this primordial broth, matter and antimatter jostled for existence. These twin entities were mirror images of each other, born in equal measure. Yet they were mortal enemies, annihilating each other upon contact in a burst of energy. It was a cosmic battle, a dance of creation and destruction on an unimaginable scale. Yet, in this tumultuous maelstrom, a mysterious imbalance occurred. For reasons still unknown, slightly more matter than antimatter was formed. This excess matter survived the violent collisions, forming the basis for the material universe we inhabit today. Imagine that, the existence of everything we know, from the smallest microbe to the largest galaxy, hinges on this minute imbalance in the early universe. As the universe continued to expand and cool, the nature of matter itself began to change. The roiling soup of particles began to coalesce into more familiar forms. Quarks, the most basic units of matter, combined in threes to form protons and neutrons. These in turn came together to form the nuclei of the first atoms, the building blocks of everything. Gluons, the particles that mediate the strong nuclear force, played a crucial role in this process. They acted as a kind of cosmic glue, binding the quarks together into protons and neutrons. Without them, atoms as we know them could not exist. This was the dawn of atomic matter, the first step in the formation of stars, galaxies, and eventually life itself. The universe was no longer a chaotic inferno, but a cosmic nursery, the birthplace of order and structure. It was a significant shift, a turning point in the history of the cosmos. And so, from chaos, the first seeds of order began to emerge. The universe, once a hot, dense soup of particles, had taken its first steps towards the intricate complexity we observe today. As the universe expanded and cooled, galaxies, stars, and planets began to form. From the aftermath of the Big Bang, the universe was a soup of fundamental particles. These particles, known as quarks and gluons, began to combine as the universe cooled, forming protons and neutrons. These in turn assembled into the nuclei of the first atoms. With the formation of hydrogen and helium, the universe's first elements were born, but the evolution of the universe didn't stop there. No, it was only just beginning. As these atoms clumped together under gravity's relentless pull, they formed the first stars. These stars were massive, burning hot and fast and living short, fiery lives. In their fiery crucibles, these early stars forged heavier elements like carbon, oxygen, and iron before finally exploding in spectacular supernovae, scattering these materials across the cosmos. These scattered materials didn't go to waste. They gathered once again, forming second and third generation stars. Some of these stars had enough material around them to form protoplanetary disks, which over time coalesced into planets, moons, asteroids, and comets. Over billions of years, the universe continued to expand and evolve, leading to the formation of galaxies. Galaxies are immense structures, each housing billions, sometimes trillions of stars. Our own galaxy, the Milky Way, is just one among countless others, each with its own unique assembly of stars, planets, and celestial objects. This process of cosmic evolution is still ongoing. Stars are still being born, and galaxies continue to grow and merge. The universe, in all its vastness, is a dynamic, ever-changing entity. From the first quarks and gluons to the galaxies and stars we see today, the universe has undergone a remarkable journey of transformation. And thus, the universe as we know it was born. However, the story of the universe doesn't end there. As we cast our gaze into the future, we find ourselves contemplating the intriguing possibilities that lie ahead. You see, the universe as we know it is always expanding, always evolving. But what happens when this expansion reaches its limit? Will it continue indefinitely, or will there be a reversal of this expansion? Current cosmological models suggest a fascinating possibility: the Big Crunch scenario. As the name suggests, the Big Crunch is a theoretical event where the expansion of the universe eventually slows down, stops, and then reverses. This would mean that everything in the universe, from the farthest galaxies to the smallest particles, would collapse back into a singular point, much like the one from which the Big Bang originated. Now imagine this. Once everything has collapsed back into this singularity, another Big Bang occurs. A new universe is born, expands, evolves, and then eventually collapses back into a singularity, setting the stage for yet another Big Bang. This idea proposes that we may be living in a cyclic universe where creation and destruction are two sides of the same cosmic coin. Just as our planet experiences cycles, the changing of seasons, the ebb and flow of tides, the universe itself may also be part of such a cycle. In this grand cosmic cycle, our universe is constantly renewing, evolving, and then resetting in an endless dance of creation and destruction. So, as we stand here, on our tiny planet, looking up at the vast expanse of the cosmos, we must remember that we are part of something much larger, something infinite. We are a part of a universe that has been around for billions of years and will continue to be around for billions more in one form or another. Our cosmos may be just one iteration in a never-ending cycle of creation and destruction, a grand cosmic cycle. So where did everything come from? A question as old as humanity itself, and the Big Bang theory provides the most compelling scientific response. We've journeyed back to approximately 13.8 billion years ago, to a time when our universe was in an incredibly hot and dense state, a singularity. The moment of the Big Bang was a cosmic explosion, a sudden eruption of energy, birthing all matter and energy that comprises our universe today. In this early chaotic stage, matter and antimatter clashed furiously, yet mysteriously, slightly more matter survived, setting the stage for the formation of everything we know. As our universe expanded and cooled, a dense soup of quarks and gluons began to combine to form protons and neutrons, the building blocks of atoms. Over billions of years, these fundamental particles coalesced into galaxies, stars, and planets, but the cosmic narrative doesn't end there. The universe's expansion may eventually slow, reverse even, leading to a big crunch where everything collapses back into a singular point. This suggests a cyclical cosmos with countless Big Bangs occurring throughout eternity, a grand cosmic cycle constantly renewing and evolving. The Big Bang Theory provides the most compelling explanation we have for the origin of our universe, a testament to the power of scientific inquiry and human curiosity. This is the story of our universe, a tale of creation, destruction, and rebirth, a dance as old as time itself.
Subscribe to the channel for more video, and please give us a thumbs up if you enjoyed this.